Okay, we're going to take a really easy introduction into square roots. You probably already know this. I've got just one little trick here to tell you that'll be important as we move forward. But the idea of a square root, which you probably already know, but I'll talk you through it, is this. Some mathematician wanted to answer a question. He said some numbers are made of the same number times itself. So 9 is actually made up of 3 times 3. So if you ever have a number like that, what's the number it's made of? So 2 of the same thing multiplies to get 9. Well, someone just made all of this sentence. The question in English is, what number multiplies by itself to make 9? Well, in math language, that says that entire sentence. And so mathematicians found it useful. Instead of saying what number times itself makes 9, they made this symbol that says that same sentence, and what you get is that number. Now, when you look here, you probably know several of these, although there's a couple here I don't. So the square root of 36 is easy. We just know it's 6. You've had that memorized. Now C here, the letter C, the square root of 81 is a 9, and we got a negative out front, so we'll just put a negative 9. Now, here's the trick I want to show you. 196. Now, I don't know that one off the top of my head, so what I'm going to do is I'm going to break this down into its prime factorization. So here's what I'm saying. 196 is made up of 2 times 2 times 7 times 7. Okay, well, in a square root, anytime you have a pair of something, you can bring one of them out. So I have a pair of 2's, I can bring out a 2. I've got a pair of 7's, I can bring out a 7. Now, we multiply them back together and we get 14. So a pair of 2's, a pair of 7's lets me bring out one of each, and I get 14. So the square root of 196 is 14. And you say, well, why would I want to do this? We're going to get into more difficult material later, and what we're going to see is that sometimes not everything comes out of the house, or we're going to have really complicated stuff with variables. So this is going to be a really important trick. Now, D here, 289, that is actually 17, I believe. And so I've got a negative out front, so negative 17. So my trick wouldn't be that helpful because the only numbers it's made of are 17. But okay, so you could use my trick. I'll use it on this to show you. But so 49 square root is 7. So we're just going to put a negative there. It's allowed to be out front. Now if you didn't know 225, let's do, or I should do it like this. Okay, so I'm breaking my numbers down here, and I've got 225 is made of 5 times 5 times 3 times 3. All right, so I'm going to take a pair of 3's there. I got a pair of 5's. Lets me bring out a 3 and a 5, and I'm going to just multiply those back together, and I get a 15. Okay, so this one you probably know is 8. This one you probably know is 11. I've got that negative out front, so I'm just going to put that out front, make it negative 11. All right, now here we run into a problem. Now later, I don't actually think in this course, but in some courses we'll talk about something called complex numbers, which will allow us to handle something like this. But generally we can't, you can't have a negative under a square root, and here's why. The square root of 169 is 13, so 13 times 13 does not create negative 169, it makes positive 169. And how about negative 13 times negative 13? Well, that doesn't work because the two negatives cancel and make a positive. Well, negative 13 and 13 is what we need, but that's not the same number. So it can't be done, and you would say there's no solution. Okay, now this B, we know the square root of 64 is 8, and the negative out front is fine. That's different. It's the negative underneath that causes the trouble. Okay, now I'm going to start here with B, and I've got that negative, and the square root of 81 is 9. Now here on A, we have that same problem again, so there's no solution. I can't have a negative underneath the root. All right, just more of the same here. The second one is no solution. Okay, now what we're getting at here is they want you to see that they're going to turn out not to be the same answer. That you can't just split a square root up at an addition sign and get the same thing. So if we work this, we get 17, 5, and 12. Now if we add first, underneath there we get 169. Well, that's 13. We do not get the same thing. So you cannot just break a square root at the addition sign. You won't get the same thing. You've got to use it like it's a parenthesis. You've got to clean up what's underneath there. Okay, we're going to see the same thing again, of course. We're going to get 3 plus 4 on the first one is 7. Now you put the second one together, we add up under there, we get 25, and we get 5. So not the same thing. Okay, now the second one here, we would get 8 plus 15. We would get 23. And now here, when we put them together, we get 289, which I believe we saw was 17, I think. So not the same thing. Now, I think this is the final thing they want us to do. I may be wrong about that. They want us to see, well, let's estimate where the square root of 60 could be found. Because we can't find it. It's called an irrational number. It actually goes on forever. And it's an important idea in math. But the best we could do here is we could put it between, sandwich it between two other numbers. We know the square root of 49 is 7. We know the square root of 64 is 8. So although we don't know exactly what it is, we could pin it between 7 and 8. All right, let's do it again here. We know the square root of 36 is 6. We know the square root of 49 is 7. So we must find that 38, square root of 38 must be somewhere between those two. All right, let's try again. We know the square root of 81 is 9. We know the square root of 100 is 10. So the square root of 84 must be somewhere between 9 and 10. Oh yeah, there's one last thing. I think this is it. We're going to just approximate square roots. We're just going to use our calculator. Some calculators punch differently. Sometimes you put the number in, then the square root, or sometimes you square root it first. But that's all it is. And they're asking us to go to 2 decimal places, which we already know how to do. So we're going to look at the second and then look at the number behind it. 2 decimal places is the 2, behind it's a 3. So that's not going to round up. It's going to stay the same. Now I'm going to do these on my calculator as well here. Square root of 11, I'm getting 3.316. So if I look at that second decimal place, 6 is bigger. We're going to go up. Now for the square root of 13, I'm getting 3.605. So if you look at the second decimal place, behind it's a 5. Once again, we're going to go up. Okay, that's a pretty easy introduction, so hopefully you did fine with that, and it's probably all stuff you already knew. My trick about how to break down square roots you may not be familiar with is going to be really important, but we'll see that in the future as we move ahead.